So let us move to the second question. So second illustration, we are given an iron ball of mass 50 gram, which is 50 into 10 raised to minus 3 kg. It is given in the question, this ball from a height of 5 meters, it falls down. And after colliding with the ground, it comes to a height of 3.2 meters. So in this case, we have to find the average force which is exerted on the ball by the horizontal surface. So how will we calculate? So let us first consider journey A to B and then B to C. So for journey A to B, we have initial velocity 0. Final velocity we will calculate. Displacement is minus 5. Acceleration is minus g, which is minus 10 meters per second square. So let us use the kinematic equation. V square is u square plus 2as. So v square is 0 plus 2 into acceleration, which is minus 10, into displacement, which is minus 5. So v square comes out to be 100, which gives us the value of final velocity v as 10 meters per second in downward direction. So final velocity v will be negative. But this is the velocity just before the ball hits the ground. So u comes out to be minus 10 meters per second. Now, let us come to journey B to C. So for B to C, we are given, we do not know the initial velocity of ball. Final velocity is 0 at point C. And displacement is plus 3.2 meters. So kinematic equation v square is u square plus 2as. So 0 is u square plus 2 into acceleration, which is minus 10, into displacement, which is 3.2. So u square comes out to be 64. So the value of u is 8 meters per second with a positive sign because it is an upward direction. So here v, velocity of ball just after hitting the ground. Just after hitting the ground means after colliding. It is 8 meters per second. So we can say initial velocity u is minus 10 meters per second because it is downward direction. Final velocity is 8 meters per second upward direction. So change in momentum delta P is m into v minus u. So mass, it is given as 50 grams. 50 into 10 raised to minus 3 kg into v minus u, which is 8 minus minus 10. So change in momentum comes out to be 50 into 10 raised to minus 3 into 18. So let us do the calculation. So it will come out to be change in momentum. It will come out to be 18 into 5 into 10 raised to minus 2. So it comes out to be 90 upon 100, which is 0.9. So change in momentum comes out to be 0.9. Now, to calculate the average force, it is change in momentum upon change in time. So change in momentum we got, it is 0.9, and time we are given, it is 0.02. So let us do the calculation. Multiply by 10. So this will be 9 upon 0.2. So one more multiplying by 10, it will be 90 by 2, which is 45 Newton. So we can say the average force, it comes out to be 45 Newton. So this is the answer to the question number 2, illustrative 2. Now after illustration 2, let us move on to illustration number 3. So illustration number 3, we have on page number 9. So in page number 9 of our class notes, we have illustration 3. So we have 3 particles, A, B, and C. So they move together. It is given in the question, 3 particles A, B, and C of equal masses move with equal speed along the medians of an equilateral triangle as shown in the figure. They collide at the centroid G of the triangle. After collision, A comes to rest while B retraces its path with a speed V. So what is the velocity of C? So we are given in the question, we have 3 particles A, B, and C. So they move towards the medians. That means they will intersect at the centroid G as shown in the diagram. Now, in this case, as the momentum is conserved, so we can say momentum of system is constant. So momentum of system will remain constant by conservation of momentum. So let us now resolve momentum of particles B and C. So let us see how to do this. Momentum of particle A plus momentum of particle B plus momentum of particle C is 0. Why? Because initial momentum of system equals final momentum of system. The initial momentum of system is 0. So we can say in that case, momentum of A plus momentum of B plus momentum of C is 0. Now, in this case, we are given momentum of A, which is 0. Why is it 0? Because it is given A after collision comes to rest. The velocity of A is 0. So we can say momentum of A is 0. Now we can say if momentum of A is 0, so 0 plus momentum of B plus momentum of C is given as 0. Now after this we can say PB, momentum of B plus momentum of C is 0, which gives us momentum of B is equal to minus of momentum of C. So mass into velocity of B is equal to mass into velocity of C. Cancels on both sides and we get velocity of B equals velocity of C in magnitude, which is nothing but V. So we can say in this case the final velocity of particle C, it is V itself. The particle B has velocity V, so particle C will also have the same velocity V, and its direction will be along BG from G to B. So that is the answer to this question. Okay. So after this, let us move to illustration 4. So we are given a stream of water flowing horizontally with a speed of 15 meters per second. It is coming out through a tube having cross-sectional area 10 raised to minus 2 meters square. It hits a wall nearby. So we have to find the force exerted on the wall by impact of water, assuming it does not rebound. So which law will we use? Force is rate of change of momentum. Now, in this case, we have the velocity of stream of water. It is 15 meters per second. The area of cross section is 10 raised to minus 2 meters square. The volume of water, it will be nothing but area into amount of water displacing per second. So volume is area into velocity. Why? Because velocity is displacement upon time, and time we are considering here 1 second. So water displaced in 1 second, displacement S. So that will be the volume. Volume is area into displacement. So in this case, we have volume V. This is the volume V. That is area A into velocity V. So area in this case, we have the value of area as 10 raised to minus 2. and velocity we are given 15. So we can say the volume of water coming per second, it will be 15 into 10 raised to minus 2. Now, if I calculate the mass of water, so 15 into 10 raised to minus 2 meter cube, this is the volume. Now the mass of water coming, it will be density into volume. So density of water we know it is 1000 into volume is 15 into 10 raised to minus 2. So it comes out to be 150 kg. So mass of water flowing out 1 second, in 1 second. In how much time? 1 second. It is nothing but how much? 150 kg. Now, in this case, if I calculate the force, it will be change in momentum, which is m into v minus u. So mass we found 150 and velocity it is 15. The final velocity as per question is 0. So we can substitute the value of final velocity v as 0. Initial velocity is 15. So we can say change in momentum is 150 into 15, which is 2250 Newton. So in this case, if I consider the magnitude of change in momentum, it will be 2250 Newton. So this is change in momentum, and because we consider the time as 1 second, so we can say the force is change in momentum upon time. Change in momentum we calculated 2250 Newton. Upon time is 1 second. So 2250 upon 1 is 2250 Newton. So this is how we solve illustrative example 4. Now moving on to illustrative example 5. So we have two billiard balls which are moving in opposite directions. So mass of billiard ball is 0.05 kg. They are moving in opposite direction, 6 meters per second. They collide and rebound with the same speed. So two billiard ball, they collide and rebound with the same speed. So in this case, we have to calculate the impulse imparted to each ball due to other. So impulse, we know it is given as change in momentum. So m into v minus u. So 0.05 into impulse in this case we'll calculate as change in momentum. So let us find the change in momentum. So each ball, first ball, if I consider the final velocity, if I consider this ball as first ball, so if I have this ball as first ball and this another ball as ball number 2 in red color. So if I consider ball 1, so change in momentum of ball 1 is equal to impulse of ball 1. So J1, it will come out to be 0.05. Final velocity of ball 1 is minus 6. Initial velocity of ball is 6. So 12 into 0.05. That will be the magnitude of impulse. So it comes out to be 0.6 kg meter per second. So this is the impulse of ball 1. Similarly, impulse of ball 2, it will also come out to be having same magnitude, 0.6 kg meter per second. The impulse imparted to each ball are in opposite direction. For example, if I consider ball 1, so ball 1, what was our value? It was negative value. That means impulse imparted to ball 1 will be in left direction. Impulse imparted to ball 2 will be in right direction. So this is how we solve illustrative example 5. Moving on to illustrative example 6. We have a shell whose mass it is given to us as 0.02 kg. It is fired by a gun of mass capital M, which is 100 kg. The muzzle speed of the shell, it is given to us as 80 meter per second. What is the recoil speed of gun? So we have to find the recoil speed of gun. So again, in this case, we will use principle of conservation of momentum. So let us see principle of conservation of momentum here. So we can say, in this case, the initial momentum Pi equals final momentum Pf. So in this case, initial momentum is 0. So final momentum is mass into velocity plus mass into velocity, where small m is mass of shell, capital M is mass of gun, and gun has greater mass, shell has small mass. So velocity of shell will be greater and velocity of gun will be smaller. So small m is mass of shell, capital M is mass of gun, velocity of shell, it is small v, velocity of shell, it is capital V, and velocity of gun, it is small v. Let us substitute these values. In this question, we have to find the recoil velocity of gun, which is small v. So capital M into small v is minus small m into capital V. So small v comes out to be minus small m capital V upon capital M. So it comes out to be, let us substitute the value. Small m, it is given to us as 0.02 into velocity capital V, it is given as 80. Capital M mass of gun, it is 100. So let us do the calculation. The velocity comes out to be minus 1.6 centimeter per second on calculation. So negative sign here shows that the gun kicks backward. So gun has a recoil in backward direction. So this is how we solve illustrative example 6. After this, let us move on to illustrative example 7. So illustrative example 7 we have on page number 16. So illustrative example 7 is on page 16 of our class notes. So in this question, we have a figure which shows traction device used in a foot injury. The weight of 2.5 kg object creates a tension in the rope that passes around the pulleys. Therefore, tension T1 and T2 applied to the pulley on foot. It may be surprising that the rope applies a force to either side of foot pulley. A similar effect occurs when you place a finger inside a rubber band and push outward. So let us see this magnitude of force we have to find. So let us see how to find the magnitude of force. So we are given the diagram. So diagram is like this. So we have two pulleys. The second pulley is attached to a mass of 2.5 kg. Now, these angles here are given to us as 37 degrees each. Let us consider the tension in upper string as T1 and tension in lower string as T2 and the force as F. So let us see force balance, how we do force balance. So first of all, let us resolve the tension. Why are tensions T1 and T2 different in value? Because the strings are different. So let us resolve T1. So component of T1 along 37 will be T1 cos 37 and component of T2 along 37 will be T2 cos 37. Also, in this case, the vertical components will be like this: T1 sin 37 and T2 sin 37. So let us do force balance now. So by force balance, what will we get? We will get along y direction, force balance will give us T1 sine 37 minus T2 sine 37 is equal to 0, because these two forces, they will balance each other. So we will get T1 sine 37 equals T2 sine 37. Sine 37 cancels, and we get the value of T1 is equal to T2. Then force balance along x direction. So what will we get? So in x direction, what are the forces? So we have T1 cos 37 plus T2 cos 37. This balances F. So let us substitute the value. So what is the value of cos 37? So first of all, let us use the triangle. This is 37 degree. So let us draw the graph of sine and cos. This is the graph of sine and this is the graph of cos. So which value is greater at 37? 37 is somewhere here. So we can say cos 37 is greater than sine 37. Because the cosine graph has greater value, sine graph has smaller value. So cos 37 is greater, 4 by 5. Sine 37 is smaller, 3 by 5. So let us substitute the value of cos 37 as 4 by 5. So T1 into 4 by 5 plus T2 into 4 by 5 is equal to F. So that will give us T into 4 by 5 plus T into 4 by 5 is equal to F. Why did I write T instead of T1 and T2? Because the values of T1 and T2 are equal. So from this, we get the value of F as 8T by 5. Now, 8T by 5 is the value. Now let us substitute the value of T as mg. So T will substitute as mg. What is the value of mass on the other pulley? So this pulley, if I consider, so I'm considering this pulley. So in this case, T is 2.5 G. That is 25. So M is 2.5. T is mg, which is 2.5 G, which comes out to be 25. So force will substitute 8 upon 5 into mg, which is 25. So 8 into 5, 40 Newton. So the value of force comes out to be 40 Newton. So this is the answer to illustration 7. Now after illustration 7, let us move on to illustration number 8. So in illustration number 8, we are given an object of mass 300 Newton. So this angle is 90. This angle is given as 37. This is string A, this is string B, and this is string C. So in this case, mass is 30 kg. So force in downward direction will be 30 G, which is 300 Newton. We have to find the tension in each string. Let us consider the tension here as TA, tension in B string as TB, and tension in C string as TC. So let us find how the value of TA, TB, and TC. So let us first resolve TC. So if we see carefully, this angle is 37. So this angle will also come out to be 37 by alternate angles. So if I have this as 37, so I can resolve TB as TB cos 37 along horizontal and TB sin 37 along vertical. So TB cos 37 and TB sin 37 I have resolved. So let me show the resolved forces. So this is TB cos 37 and the vertical one is TB sin 37. TB cos 37, it is balanced by TA along horizontal direction, and TB sin 37 in upward direction equals TC plus 300. Let us see how we will apply this force balance. So first let us calculate the value. Let us find the relation between TA and TB. So we found TA. It is TB cos 37, which is TB into 4/5. So TA is 4 times TB upon 5. This is our first relation. Now, after this, we have to find the value of TA, TB, and TC. So let us use other equations. So we have other equation as TB sin 37. This will be balanced by TC. We will not have 300 here. Why? Because in this case, we have the diagram. In this, we have this part here. So here we have in upward direction TB sin 37, and in downward direction we have TC. So these are the only forces at this point. So 300 Newton here, it will be in the free body diagram of 30 kg block. So here we will have a force balance of TB sin 37 and TC. So our equation will be like this: TB sin 37 equals TC. So let us substitute the values. Sin 37 is 3/5. Let us substitute the value. TC comes out to be TB sin 37. Sin 37 is 3/5. So TB into 3/5. So TC comes out to be 3 TB upon 5. This is equation 1. This is equation 2. Finally, let us draw the diagram of 30 kg block. So downward direction we have 300 Newton, and in upward direction we have TC. So from this, what can I say? The value of TC, it will come out to be how much? So let us see, TC in this case comes out to be 300 Newton. So now once we find the value of TC as 300 Newton, let us substitute this value in the other two equations. So TA is 4 TB/5 and TC is 300 Newton. So let us substitute this value of TC in this equation 2. So equation 2 says TC is 3 TB upon 5. So TB comes out to be 5 TC upon 3. So 5/3 into 300. So TB comes out to be 500 Newton. So TB is 500 Newton. Okay. So we got two values. TB is 500 Newton and TC is 300 Newton. Now let us find the value of TA. So let us use this equation, equation 1. TA is 4 TB upon 5. So TA is 4 TB upon 5. So 4 into 500 upon 5. 400 Newton. So TB comes out to be 400 Newton. So we can say TA comes out to be 400 Newton. Yes. So in this case, we have found the value of TA. It comes out to be 400 Newton.